Okay, it's easier to. Okay, so we all we want to do is find dm. So it's plus or minus c1 times e to this times dt. And times 0.05. I swallow the 0.05. Okay. So then dm equals, I'm going to put these two constants together, plus or minus c1 times 0.05 times e to 0.05 t dt. Okay, so now all we need to do is realize that plus or minus c1 e to 0.05 t, this piece is m. We already have it here. So then dm equals 0.05 m dt. To go back to the original, we just divide both sides by dt. So we had dm over dt 0.05 m. And this is what we started with. Okay, so now let's choose. We need a lot of practice, I know that. So let's choose the next from the next set, from 21 through 25. It is very important for this section to work through these problems again several times. Okay, I'm ready. You choose or I will. I hope I didn't scare anyone. Is anyone with me?
Can we do 25?
Yes. Very good. So let's look at 25. And this is still on 535. And 25 is dB over dt equals 0.03 b, and b of 0 equals 500. Perfect. The difference between these two, so they are the same, but the only difference is that we can determine the constant given the initial condition. Good. So how do we proceed? What is the first step? It's okay if you're wrong. We're studying this, so please talk to me.
Divide sides by b.
dt, very good. So we have to multiply both sides by dt first. 0.03 b dt. Yes, we divide both sides by b. dB over b equals 0.03 dt. It's all the same so far. Okay, at this point we do what? So we multiply both sides by dt, then we divide both sides by b. What is the next step? What do I need to do next?
Define the integral.
Yes. Integrate both sides. Awesome. What about the left-hand side? What do we get from the left-hand side?
Natural log b.
Yes, but please remember it's the absolute value. Because if we don't put the absolute value, it would be incorrect. Good. On the right-hand side, I know you're going to say t plus a constant c. But we are told that b is 500. b is 500 when t is 0. b is 500 when t is 0. So how much is c? Careful, natural log, right?
Oh.
You're right. So, but natural log. So, natural log of 500. There is no need for absolute value because it's positive. 0 plus c. So c equals natural log of 500. Good. So I can put it back in. I can write the solution first or put it back in first. It doesn't matter. So as we know, this is e. So the absolute value of b equals e to this. So e to 0.03 t times e to natural log of 500. 0.03 b plus natural log of 500. So I separated already. Now this is another property of the natural log, or log, any log. A raised to log base a of x, these have to be the same, and they are. The base of this and the base of this, they're all the same. So both the same. So this is x. So this number will equal 500. In case you forget this property, it's a slightly more sophisticated property if you want, but it's not a problem. You can plug it in. So all you have to do is just write e raised to power natural log of 500. Careful with parentheses, you know me. So when I hit enter, I have to get 500, mandatory. Okay? So again, this is a property that is less discussed, let's say, in algebra classes, more in pre-calculus and calculus. We know all the other properties, but we really don't emphasize this that much. You can plug it in and you know it's 500. So then the absolute value of b equals 500 e to 0.03 t. And now I have to write b equals plus or minus 5, because from the absolute value, 500 e to 0.03 t. But now careful. Careful, because we were told that b of 0 is 500. So please plug in 0 here and tell me what you get. When we plug in 0, this is 1, and we have to get only positive 500. So I will have to say no, only positive, because this will be incorrect then. And this was given to us. So then b equals 500 e to 0.03 t only, not plus or minus. Because if I put minus, when t is 0, I get negative 500, but that's not what I was given. So I always have to go back when I establish the final solution or determine the final solution. I have to go back to the initial condition, especially when we have two possibilities. Okay, I have two possibilities from the absolute value, but only the positive one works, because otherwise b of 0 will not be 500 as given to us. Any questions on this problem? I'd like to move on, and you tell me what you would like to work on next. Where is my book?
Did you pick the problem for us?
Yes. All these are exactly what we just did. L is 1200 when t is 0, but I like to choose from here now. And this is the last step before we look at word problems. Okay. So, I don't know, let's try 33, and then you choose the next one. 33, but this time we are on the next page, 536. Okay, so we have 3y squared dy over dx equals 5x. So solve by separating the variables. And we're not given an initial condition here, so we're going to determine the general. Then we're going to look at this set. We're going to choose from maybe another one from here and another one from here. Okay, perfect. Can anyone give us an idea of how to start? What do I need to do first? In order to
Multiply both sides by dx.
Of course, excellent. So 3y squared dy equals 5x dx. Are they completely separated? Y only here and x only here?
Yes.
Perfect. What is my next step once I've separated them?
Divide by dx.
But then we go back.
Integral. What's that?
Say it again, Sierra.
Integral.
Yes. After we completely separated the variables, Then we are integrating. Awesome. Don't look at this one. And notice we are only using one c. There is no need to use a c here and a c here. One is good enough. So can anyone tell us which function prime is this?
Y cubed over 3.
Very good. Equals.
X squared over 2.
Awesome. Plus a constant c. Great job. Yes? So what I have right now is y cubed equals 5/2 x squared plus c. We are solving for y. This is just algebra now. How do I solve this equation for y? What do I need to do to both sides?
Cube root it.
Yes, awesome, excellent. Not term by term, be careful. I'm not saying you said that. Nobody said that. I'm just emphasizing. So this is y. There is no plus or minus for cube root. And this is it. We solved for y. Let's review the steps one more time. I'm given a differential equation. I have to separate the variables. I multiply both sides by dx. I get this. I take a deep breath and I look. I inspect this. Y is on one side, x is on the other. Awesome. Now I can integrate. I integrate the left-hand side without looking at the right-hand side. I integrate, I get this. I integrate, I get this. The function is y. I simplify. And now this is a cubic equation in y. I had to apply the cube root to both sides. The cube root of y cubed is y. And this stays as is. No one can simplify this, and this is done. Any questions? Okay, so please choose another from here, and then we'll choose one from here. This is, I think, the most involving section of the course, in my opinion.
Did we do 41?
Yes, 41. Let's choose before 41. We'll do 41. Let's choose one more from here. I wrote it down. 41 will be next. I want 36. Very good. 36 is good. Same page, 536. We have dy over dx equals 2x over y. Perfect. And then the next one is 41. Good. First step. What do you think we need to do?
Separate y and x.
Yes. Perfect. What would be the first step to do that?
Multiply y by both sides.
Okay, perfect. We want to start by multiplying y by both sides. Multiplying y to both sides. So dy over dx equals 2x. Good. Good first step.
Multiply by dx.
Awesome. Great job. Perfect. Are they completely separated?
Yes.
Perfect. What will be our next step then?
Integrate.
Very good. Don't look to the right. Just tell me what to write for the left.
Y squared over 2.
Awesome. Don't look to the left. Tell me what to write for the right.
X squared over 2.
Perfect. Or you already simplified. Very good. You're way ahead of me. Perfect. So we simplify. So I'll multiply both sides by 2. You can feel free to change this into C1 if you want to, or you can keep it as is. Good. Now this is all algebra. I need to solve for y. What should I do to both sides to solve for y?
Square each side?
You mean take the square root?
Yeah, square root.
Awesome. But this time I have to write plus or minus because it's a square root. So the square root of 2x squared plus 2c, or replace this by another c, or just c, doesn't matter. So this is it. You can say, but which one, plus or minus? I have to keep both. I don't have an initial value or initial condition. If I had, I would have known which one to pick, but I don't, so I have to keep both. Both. Here, on a previous example, I had this initial condition. So I knew that negative would not work, because when t is 0, the answer has to be 500, not negative 500. But this is the most general type in which I have to keep both. That's what I have. Perfect. Any questions on this? As you see, some of them are easier, the ones in which we have to just simply algebra, take the cube root or the square root. But some are a little bit more involving because we needed to solve a logarithmic equation. E to this power equals that. So you saw 3 different types so far. Not types, they're all separable, but different types of solutions, I would say. So we are looking at 41 now.